So yesterday we talked about the relationship between the exponential and natural logarithmic, correct? So the domain and the range of them is opposite. So in order to find the domain for a natural log function, we have to remember one thing, that is whatever in the ln must be greater than 0. So this is the true fact. So please remember this. Whatever in ln must be more than 0. So this will help us to find the domain. So for this case, the domain will be whatever in the ln means the whole expression, 5x minus 1 must be greater than 0. So my x must be greater than 1/5. Okay. Can or not? So this question, I didn't ask for vertical asymptote. So this will result. So this is something extra. So therefore, I can also conclude vertical asymptote is x equal to 1/5. So you see, exponential, we have horizontal asymptote. And how we get the horizontal asymptote for exponential? We study as x approaches infinity. So for natural log, if you want to find the vertical asymptote, then you have to refer to the domain. Okay? So that is first thing, you must see the relationship. Okay, now for part B, if there is any things that is unclear, please let me know so that I can explain further. Okay, for part B, find the x-intercept. Okay, can I call any one of you and try to give me the answer? Brenda? Brenda, can you talk? Hello, when I call you, please respond. If you don't respond, I'm going to set a rule that will make you respond. I will record down your name, and when come to SAT, I will deduct your mark. Hello, Brenda? Yes? Oh, you are in the library. Okay, please respond to me, okay? Okay, you are in the library, then I won't ask you. Anyone that you can, yep, okay. Okay, so it's okay, Brenda. Okay, so you got 2/5. Okay, so we know that if we want to find the x-intercept, we put the y equal to 0, correct? So that means my ln 5x minus 1 equal to 0. Okay, so when you want to find the value of x, which is in the ln, you have to change it to exponential. So exponential, the base is e. So whatever in the ln now, is equal to e to the power of 0. And we know that e to the power of 0 is 1. So we solve for x. So my find x equal to 2. So my x equal to 2/5. So this will be the x-intercept. Clear? Okay?
Yeah.
Okay. So for part C, we are going to find the y-intercept. Means we have to substitute the x equal to 0. So you look at the domain. Can x be 0? No.
No.
So in this case, I don't have to substitute. Look, if in this case, correct, if you do your question like C, you do like that. You sub your x equal to 0. So you see no solution. You do like that. Okay. So this answer, compared to this answer, from A, x is greater than 1/5. So x cannot be 0. So therefore, there isn't a y-intercept. Okay, now if I answer this, okay, solution 1 and solution 2. Okay, as an examiner who marked the paper, answer for part 2 show that the student is more observant than the answer for the first answer. So it's up to you. I'm not saying the answer is wrong. That means the person straight away can know that from the domain whether the x-intercept exists or not. So this will be I consider as a A+ student's answer. Do you see or not? So sometime in the exam, you may get all correct. Yeah. As a teacher, I may not give you A+. Do you get me? It's the way you present your answer that will show an A+ student. Are you clear? So in this case, there isn't an x-intercept because x can never be 0 from part A, because x is always greater than 1/5. So it's from 1/5 onward. Is there any question on this? Hello? No. Okay, good. So we shall go to part D. Describe the changes of fx as x approaches 1/5 from the right. Okay, I'm going to explain this, okay, from the graph. Can I? Okay, I'm going to explain this from the graph. Okay, part D, So we know that for this function, correct? The graph only exists here. X equal to 1/5. So this is the vertical asymptote. So the graph only appear here. Okay? Can? So I want to know what happened if x approaches 1/5 from the, this is called from the right side. This is the right. Okay? Understand the meaning? Yes? If no response, I say you understand what I mean. So I will write down as x approaches 1/5. So since we only have one term, so I ask myself, ln phi x minus 1 will approach what? So this is a question mark that we have to solve the problem. How we solve it is exactly like exponential. How we solve it? Approaches 1/5. We write here from the right. Okay, so which means that my x value, so this is how I imagine. So which means that my x value must be very close to 1/5, which means that it must be more than 1/5, but close to it. Understand? Do you get me?
Yeah.
Okay. So now if we imagine that it's close to 1/5, so it's more than 1/5, which means that our ln phi. Okay, can you give me a number which is very close to 1/5?
0/10.
3/10. 3/10. Yeah. So thank you for the number. So 3/10. So if you imagine -1, so it will be ln what?
0.5.
Yeah, ln 0.5. Thank you. So ln 0.5, correct? As long we know that it true facts. If you don't have a calculator, you know true facts. Ln 1 is 0. Am I right? You try to use your calculator and get. So these are something that you have to remember. Ln 1 is 0. Am I right? Hello? Because if I change it to e to the power 0 is equal to 1, correct? True. Ln e equal to 1 because e to the power 1 is equal to 1. E. So that's why ln e equal to 1. See that? So these are the relationship. So I know the true fact. Ln of a number, a positive number less than 1, the value is negative. The closer is it to 0, the more negative it will be. Got it? Hello? So these are the few true facts that you and me must remember if you don't have a calculator. Any question? So.
Miss, I can't see the thing under the positive number less than 1.
Oh, you can't see it.
Yeah, it's covered with the.
Okay, never mind. Ln positive number less than 1. Okay, the value I wrote it. I will write it here. The value is negative. So this is the true fact that the closer is it to 0, the more negative it will become. So you can imagine if it okay, so if this one is very close to 0, so look, I can, okay, if I don't want to put it like that, over here, I can put it like this first. Without the log. So if x approaches 1/5, 5x minus 1 will approach 0. Am I right? But it's not 0. So therefore, my y, which is equal to ln 5x minus 1, will approach negative infinity because of this. Do you get me? Hello, class, are you okay? Yeah. So for natural log, we always ask you to study what happened to x, what happened to the function as it approach the asymptote, vertical asymptote. So this is called the vertical asymptote. So it will go so just now we know that the x-intercept is 2/5, am I right? Here. So the graph will go like that. It will go negative infinity. Then you will here go positive. It will go this shape. Natural log function, the shape of the graph will be the inverse of exponential. So are you clear?
Does it never go 0? Like y equal ln?
No. What do you mean by it never goes 0? It can go 0. The y can be 0. So you see, so therefore, if I'm talking about the range, that is all the possible value of fx. So I will say fx is a member of real number, and that's it. That means it can be any real number. It can go very positive and very negative. So far, so good. Any doubts, please clearly. You have to know these two functions pretty well.
Like when you want to describe it, like describe how describe the changes of fx. Like
Yeah.
you use minus infinity.
Yeah. So the answer for this part, you will say, therefore, as x approaches 1/5, if you write like that, actually you answer the question already. So in max, correct, when you talk about, when you talk about describe, doesn't mean that you have to use word. You can use symbol. So you have described it. If I do this, I describe it. Okay, the person say you can't really understand. May I know which part? There are certain things that you have to accept the fact. It's not a matter of understand or not. You have to accept the facts, the nature of this function. May I know which part you don't understand? You have to let me know. If not, I'm not able to explain. 5x minus 1 is greater than 0. Okay, let me go back to this slide. The reason is because if you take out your calculator, because when we say e to the power of anything must be greater than 0. And when you talk about ln, it is the reverse. Ln anything, okay, here must be greater than 0 because of here. So this one must be greater than 0. Not that, then which is the one? This one. Okay. So for this one, that's why I say you have to imagine. The question said, study what happened to the function when x approaches 1/5 from the right. So that means x must be more than 1/5. So this is called approaches x from the right. That means your value is here. See or not? That's why your friend gives 3/10. Do you know why your friend gives 3/10? Because if I look 1/5, I have to change to a bigger denominator. So isn't it what 2/5 is less than 3/5? 3/10? So if you want to make it nearer, so what I can do is I can put here 4/20. So I put here 5/20. So this is much nearer. And you can take out your calculator and do the things. So that's why max is very important. When I say approaches x 1/5 from the right, that means I want the x value to be very near 1/5, but more than 1/5. You get me? Okay, so very important, huh? So far, so good. Okay, I try to not to introduce too much thing to you. Actually, in my mind, I got one thing. So can I set another question for you to try? Okay, so I shall go for another question, huh? Almost the same, but I change a little bit and I see how you do the thing, okay? Is that okay? Okay, let's go to another example, okay? Okay, the fourth part. So I give you around 5 minutes to settle it, then I will start to describe, okay? Okay, so first thing for part A, you know, you have to take care of this. Yep, am I right? To find the domain. So we say 2 minus x must be greater than 0. So if I have two terms of ln, then I have to settle all. Okay, that one I will give later. Okay, so my negative x must be greater than negative 2. Okay, so therefore, the x, when you have a negative, you divide by negative, you have to change the sign. Am I right? So therefore, we say the domain is equal to x. X must be a member of real number, and x must be less than 2. Okay, just now there's one of your friend who said that, can I just leave this as an answer? You can leave this as an answer, but I will not give you a A+. Do you get me? Because this is the proper way to tell people that domain is a set of number. So it's your choice, your presentation. So same thing like your EAL, the way you write. So Max also is a language, is the way you write, the way you communicate with people. You get me? So I will leave it to you to present your answer. Yeah, so don't get the habit of, in Max, correct? Don't get the habit of after you calculate, that is the answer. No, because you have to interpret the answer, you have to write it down properly. Okay, so that is the domain. Yeah.
Wait, Miss, then what would be A plus?
Okay. No. I told you already. So when you also can write as what? You also can write like that. If you don't want, you also can write like this. Now, this is called different way of presenting. You still remember? Okay. So depend on you. You see the bracket that I use. So whichever way, you just choose one way of it. Hello?
Yep.
Yeah.
Okay.
So we are not going to, I'm not going to restrict you to only one single way. So there are many ways of doing it. So as long as you don't just stop here. It's not good to just stop there. Are you clear? Are you sure that is the domain? I'm going to show you to you tomorrow. The way you write the domain. Whatever you calculated, that doesn't mean it's the domain. It can have other factors that affect it. So we have to make a conclusion of that. You get me? So to get an A+, your communication skill in Max must be very good. Understand? Okay, let's go to B. Find the exact value of the x-intercept. Exact value, that means, okay, I'm going to show it to you. Okay, so I want to find x-intercept. I must let y equal to 0, sorry. So I will say ln 2 minus x plus 1 equal to 0. Yeah, so my ln 2 minus x is equal to -1. So my 2 minus x is equal to e to the power -1. So the x, 2 minus e to the power -1 is equal to x. So the better representation will be said, therefore, x-intercept is 2 minus, if you want to change this to here like that, also can. If you don't want, it's fine. So this is called exact value. If you use calculator and count, whatever you get is approximate value. So this value definitely is greater than 0, okay? Because 1 divided by 2 point something is less than 1. Yeah, okay. Are you clear? Okay, let's go to part C. Find the y-intercept. So I will write down F0. So it's ln 2 minus 0 plus 1. So this will be exact value you will write as ln 2 plus 1. Are you clear? So this is the exact value. So therefore, y-intercept is ln 2 plus 1. Okay. Are you okay? Okay. So I'm going to, any question?
Yes.
Yes.
When you, for question B, when you bring over the ln to the other side, how come it become like, it become power for the negative?
Yeah, that is the way to change. So you have to remember not how it become. That is the formula. If I have ln A equal to B, so this is something that you have to remember. So like when you're in a primary school, when you memorize multiplication table, ln A equal to B, so my A, it will be e to the power of B. If I have e to the power of C equal to K, then I will say my C equal to ln K. So that is how you do changes between ln and exponential to ln. And when can you do it? When there is a single ln here and single number here. And this is single exponential, single number. So this is the rule that every one of you must remember. Do you get me? That is the relationship between exponential and ln. Have I answered your question?
Thank you, yes.
Yeah, so you have no choice. Get me? Okay, I'm going to describe part D. Okay, do you know part D? I said describe the changes of fx as x approaches 2 from the left. The reason why the question is set in such a way that it said to the left, from the left. The reason is because here. So if I use just now the graph to let you have a look at it for part D, my vertical asymptote is x equal to 2. Correct? So my graph, because my x value can only take the value from here onward, that is called x less than -2. So I'm going to study what happened to the situation as the value of x approach here, which means I must choose a value that is less than 2, but very close to 2. You get me? Okay. So now I will study like that. See, fx. Okay. As x approaches 2, I write here from left. So what happened to my 2 minus x? So I imagine like that. 2 minus a number which is very close to 2 but less than 2. Can someone give me the answer? An example? Can someone give me an example? Okay, 1 is not close to 2. 1 is 1 unit away from 2. When we say approaches 2 means very close to 2. Okay, you give me 9/5. 9/5 still not very close. Why don't you give me in a decimal form? Yeah, 1.9. Or I say 1.999. Correct? So this will be 0.01. Correct? So as it go closer, so this one will approach what? Approach 0, am I right? So what will happen to my ln? It will approach negative infinity. Just now, we know the true facts about ln, correct? If the number is less than 1 and is very close to 0, ln of that number will be equal to negative infinity. So therefore, my fx, which is ln 2 minus x plus 1. I owe people 1 trillion. You give me $1, can it save me? Definitely cannot. It will approach negative infinity. Hello?
Miss, I have a
Get me?
question.
Yes, why not?
If if you're approaching to x, I mean, if the x is approaching to 2 from the left side,
Yeah,
doesn't that mean the fx goes up because you can't touch the x asymptote?
yeah, it can't touch. I didn't say it touch. I say
Doesn't
it
that
go
mean
very close.
doesn't that mean it like fx goes really high?
No, you try to key into your calculator. You try to key in ln 0.00001. So what it give you the value? Key into the calculator. If you can't imagine, you key into the calculator.
Negative 11 point something.
Negative what?
Negative 11.51 something.
11.15, correct? So
Yeah.
you try to key in some more ln 0.000000001. It will always give you negative value. So when I say approach 2 from the left, that means it's go in this situation. 2, take away 1.9999999999999. It's very close to 2, but it cannot be 2. So that's why when you talk about limit, right, you have to imagine.
I see. Okay.
Okay, so you have to
I thought,
imagine.
yeah, I wrote the graph really wrong.
Yeah, so the graph will go in this way. Okay, I give you a rough sketch of the graph. Don't worry about this graph sketching. I will teach you how to do. So I think the graph will go in this way, if I'm not wrong. This is your x-intercept, which is 2 minus 1 over e, and this is your y-intercept. So you go like that. So are you okay? So this part, there is no graph on this part. The reason is because of the domain here. Okay, there is a lot of things for you to learn. Yep. Okay, spend some time, go through all the examples in natural log and exponential. So tomorrow, the class, a physical class, I will give you 2 examples, one on exponential, one on log. Then you see how you work about with it. Before I get into the next function. Because your add and drop will be end this week. So next week, I will go full force on the prepare for your SAT 1 reading. Okay? Okay. Thank you, class. I have another class to go to.
Thank you.